Okay, so on this question, we have this function. I'll just call it f of x, whatever. 2 log base 3 of x, it's right here, plus 19. And they want me to, the ddx means derivative. So they want me to take the derivative. They want f prime of this. Okay, so the first thing we need to do is take the derivative of this piece. Nope, the 2 will just sit there. But what about log base 3 of x? We haven't really done derivatives of log functions other than ln functions. Remember that? So let me give you those rules. So if you have the ln of x, remember the derivative is just 1 over x, right? Okay. Um, Remember, and so how are we going to do this, do you think? Well, think with me for a second. Do you remember e to the x and what his derivative is? That's our favorite one. He's just e to the x, doesn't do anything. And then what if you have something just like him, like you have, I don't know, whatever, 7 to the x or whatever? What would be the derivative of that? It would be Remember how that one does almost the same thing as e to the x, meaning it just does a mirror at first, just like e to the x, because it's just like e to the x, except it's 7x. Then times what? ln of 7. That's what I like to call the adjustment because it wasn't e. It wasn't the perfect number. It wasn't e to the x. E is the perfect number for derivatives. It was something else. So it does kind of like e to the x. It mirrors it, but then it has to have an adjustment. And that adjustment is multiplying by the ln. Well, the same thing is going to be true when we take log base, whatever, let's say 3. I'll just do 7. I'll do 7 since we're doing 7 here of x. Now, log, because remember what ln is? ln is base e. ln is a shortcut way of saying log base e, and it comes out to be this beautiful clean 1 over x. So then if you have another log that's not got the perfect base, what's it going to do? It's going to do 1 over x at first, just like the one with the perfect base, but then it's going to have an adjustment. What adjustment? It's going to multiply by, now, you might say, oh, you mean it's going to be like ln 7? Yeah, except it's going to put it on the bottom instead of the top. Why? Because logs are all about dividing and putting in the bottom, and exponentials are all about multiplying because they're the opposites. So like logs and exponentials are the opposite. Exponentials multiply things, and they come by exponential growth. Things get bigger and bigger and bigger, and logs are the opposite of that. So that goes in the bottom. So anyway, you don't have to memorize these. You can use your notes, write them in your notes for the exam. But I want you to see the pattern. That'll make math and science a lot easier for you. Is if you notice that there's patterns in everything. If you catch on to the pattern, it's really pretty easy. You don't have to have a great memory. You can come up with the stuff by following the pattern. So one more time, e to the x is our favorite one. He does nothing because he's perfect numbers. You have something else with x in the power zone. It does the same thing, but then there's the adjustment because it's not the perfect number. The adjustment is times ln of that number. Well, likewise, ln is base e. He just does his derivative is 1 over x. So if you have a different base log, it does the same thing, but the adjustment in the bottom for log. All right, let's get back to it. There's the rule. Here we go. So the 2 is just going to sit there. We know that. Now what's log? It's, well, when you see this, you need to think, oh, it's like 1 over x, right? It's pretended it was ln of x. What would you do? 1 over x, but it's not the perfect ln, which is basically so you got to multiply by 1 over ln of 3 for the adjustment. Plus, and what's that 0? Derivative of a constant number, not multiplied, but just not multiplied by x, but just added, subtracted all by itself with no x at all is just 0. A constant number doesn't change, right? Derivative is all about rate of change. Constant number doesn't change. It has 0 change. All right. So then can we simplify? You could just type it just like that. That's basically what they did. I guess they put the 2 in the top. Okay, sure. You can do that if you want. It's 2 over 1, right? So it goes to the top times 1 over L 3. Of course, they didn't write the 0, so we don't need that. Parentheses around that. There we go. So we got our 4 rules over here. Basically, those are our 4 rules in this section of the course about logs and exponentials. There's all the derivative rules.